Hi, Joe Cerrone.
And Al Rosen.
Welcome to CAD 107 in our weekly Zoom classroom meeting. Alrighty, so as we take a look at our main splash page, we've released a final lecture, which we'll talk about in a couple of minutes here. And basically it outlines all the chapters from the textbook that we wanted to cover for this course and talks a little bit about the future of 3D printing. We look at our calendar. Module 9 assignments are due today at 11:59 p.m. May 3rd will be when the final exam will be available. And so that will be available next week, and that will use Honor Lock. It will just be the multiple choice portion of the test, or the fill in the blank, where we talk about the information that is covered in the textbook chapters. You can use your textbook. It is open book, open notes. Module 10 is due May 7th, and then all work is due May 10th. And so everything needs to be turned in May 10th, the latest date. We take a look at the content section for our last chapter, our last project. We're working on this ring design, and you can design any type of ring that you want. It doesn't have to be the oak leaf. If you look at the project itself, I've kind of worked on this ring a little bit myself. You can download the student file, and then you can mic up a ring that you currently have to be able to make it to the proper size. And so I found that I need to make mine at least 20, maybe 22 millimeters in diameter if I'm going to get that to fit. And then we just take the dimensions from our textbook. And what we are doing is we're using dual extrusion technology. And so if you look at the video from last week's Zoom meeting, we're showing you that you need to line up the different objects in 3D Builder to make them align in the slicing software. We take a look at that project itself. We're basically working on a number of different projects. The ring actually came out relatively decent. I found that if we're going to work on the ring design, that we might want to have to flip this over and print this with this side down on the glass. It's a bit detailed for the ring. I think maybe the way to do this would be to create the negative shape and then print this with an SLA printer and then just glue them in. You'll see that we used inserts, support material for it. And then you can see the bigger they are, the better they come out, I think. As we take a look at, we put a brim on them so they stand up. And then we were able to print some with just plain bridging, where we're able to go through and create that. But as we start to work, the next thing is to work with what they call dual extrusion, where we're assigning one extruder one material and then the other extruder the other material. The technique that we've been using for the design aspect with single head extruders has been to create the shape of it and then create a negative shape, which is subtracted out, and then to print this in a different color and just glue it in. And that technology works pretty well from a standpoint of how we're creating these different things. Make sure that you spend some time to come in and pick up your projects. We'll have your projects at the door in a Ziploc bag for you to pick up, and you can then bring those home. They make great Mother's Day presents. All right, back to the main splash page. I'm going to go back and share my screen again. We're going to take a look at the PowerPoint. You can download the final lecture PowerPoint right here. If I click on it, what we've done is summarize the materials and things. And so if we look at chapter 14 of the textbook, it talks a lot about different types of materials and the future of 3D printing. Things like printing food, medications, and bioprinting are future needs that 3D printing is going to come into. And you're welcome to take a look at some of these YouTube links. Architectural aspects of 3D printing homes. This is what they talk about when they talk about colonizing other planets, like putting housing up in Mars, where they can actually go and use the materials on the planet to be able to then extrude and create a home. And so they talk about that in NASA's challenge in these remote environments. I thought this was kind of a neat YouTube. Looks like I'll have to skip through something here. Mosquitoes. But they have these NASA challenges, and you're welcome to join in some of these clubs at the school if you are interested in some of these aspects. But this project I thought was appropriate to kind of show how engineers are working on using 3D printing technology to create these different environments for space. All right, let's go back to our PDF. You want to know what 3D printing is, be able to define that. It's not really printing, it's really additive manufacturing. As we start to work with the technology, we've used 2 textbooks. We've used our Mastering 3D Printing in Prototyping, and then we've used our 3D printing projects. Our first 3D printer was the Stratus Dimension that we purchased over 20 years ago, so we're quite good with 3D printing over the years. The price has come down significantly from $30,000 to now these desktop printers, which we can pick up for around $2,000. And that's what we've done. We've brought in these Dremel 3D printers where everybody gets an application to use it. They have fully enclosed controls. They have an RFID reader, which will tell us what type of material we're using. The print volume is 10 by 6 by 6. It's actually a little bit less than this because typically you'll have to have some kind of build plate adhesion that'll take up some of the space. Got an LCD screen. We're using USB, but they are Wi-Fi and Ethernet capable, which allows us to slice them in the cloud and be able to run the course online. So they're a nice standard way to learn 3D printing. We've had those printers for 5 years now. As far as working with manufacturing, historically, we want to know the difference between working with like a CNC machine versus a 3D printer. And so this YouTube gives a good example of 3D printing, of CNC machines and how a CNC machine operates. And we have those machines right here in the lab that we're working in for 3D printing. So you can get an application for all these different methods for creating different prototypes and things like that. And then we have our desktop 3D printers. And so here's our Maker Gear and our Ultimaker. These have dual extrusion. This is what we'll be using for the last project. Students who want to go and build their own, you have to be a little bit careful because they are quite sensitive and they just lead to more investments if you get something that's not up to the right quality level. We recommend the Prusa printer as far as if you're going to build it from a kit. That seems to be the one the students like the most. And then as we're looking at these different types of filament, we want to know that they come in different diameters. For the Dremel printers, they 1.75 millimeters and 2.85 millimeters for the Ultimaker printers. But typically, most of our filament is 1.75. And then as we look at the types of 3D printers, we have these Cartesian printers, Delta bots. Here's the Prusa. I think it's gone up a little bit, but This is a really good quality printer. And from what I've heard, they're using these at some of the other high schools as well, from a good standalone type of printer. What we tried to do was to get into 3D print design considerations, how to design for 3D printing, and then how the 3D printers work, and then components for 3D printing. We use these textbooks to go through and outline the lecture material, and then tie it into our work within the course. And so things like the history of 3D printing, whether you're going to buy a kit, when to use a 3D printer versus laser cutting or other prototyping type of technologies like CNC machining. And then you should answer the questions at the end of the chapter, which will allow you to then demonstrate your understanding of these different concepts. And so as we go through these different chapters, we looked at 3D printers and printable materials, filament-based printing, FDM, open deposit modeling, and then how the operation of 3D printers works. And we wanted to have everybody to have a good understanding of the Dremel 3D printers for those of you who are coming in to use the 3D printers, knowing the proper terminology like the extruders, Bowden tubes. And then we tied them into these different projects. And here's an example of some of the projects that we use to create. Some of the problems that we'll have, and we do get a lot of failed prints. It doesn't work perfectly. The technology hasn't gotten to the point where it's super reliable, but it is better. We do get about a 10 to 20% failure rate on 3D printing. And it really comes down to if it's the first time you're printing it. And so things like knowing what orientation to set things up in so that they're properly printed, being able to calibrate the 3D printers and make sure that they're working properly, and then being able to orientate things in the slicer. We talked a little bit about where you can get models. So you can get models from Thingiverse. You want to get yourself a pair of calipers so you're able to go through and make measurements. We talked about different types of filament. Polylactic acid, PLA, is probably the most commonly used. It's biodegradable. You can get it on Amazon Prime. You can get it delivered the next day. And then post-processing. And so as we look at working with single head extruders versus multi versus dissolvable print material, or having to take out the support material, there's quite a bit of work that can be involved in post-processing. And so our plan was to go from design to slicing to printing. And as we look at these different areas, we want to be able to understand the different file types, like CAD versus STL, standard triangle language. And then there's some links for things like where you can get different prototypes and models. And so if you were in a class and you were studying things like history of the world and you wanted to print out some type of an example, you can go to these different sites and get these very high quality 3D prints. Things like the Discovery Channel has 3D prints, GrabCAD, other areas. So you don't have to necessarily design it, but it is opening a new market too, where you actually buy your 3D printed materials or your 3D printed models, and then you can 3D print them. We want people to have a good understanding of the slicing software, and so we did spend quite a bit of time going through slicing, and then different types of printing like SLS, selective laser sintering, using powder-based support material to turn it into metal. Some of our labs designing for 3D printing, knowing that if you are going to print something, you can't just have it hanging out in space. It has to be connected. And so we did other work with creating negative and positive. We worked a considerable amount with CAD. AutoCAD was our main video program, but we're seeing a lot of people use Fusion now in SolidWorks. And there are certification exams for those softwares if you are interested. And then we looked at some of the design rules for 3D printing. working with filament-based printing, how much overhang can you have before it fails? And what is overhang? And so in this PowerPoint, we'll give you an opportunity to talk a little bit about that. Things like bridging, how much area can you cover before it starts to sag, or you just get a complete fail? And then we worked with special modes of printing, things like spiralized outer contour for these vase prints that allows you to cover a lot of material in a large build volume very quickly. And so there's some information on that. And then the author has some other books out there for 3D printing, as far as like what they call the new shop classes, or what we call digital manufacturing and prototyping. And so as you look at the questions for the review, you're going to want to be able to understand and know how to demonstrate what 3D printing is, the different types of 3D printing like FDM or SLA, a little bit about the history of 3D printing, some information about terminology, being able to understand the different CAD files and formats, identify the different parts of a 3D printer and how it's used. And so as we look at our lecture and our review from these different chapters, here's some information to help you study for the test, which reviews our content for the course. And so this might be a little bit too much. There's quite a bit of information, but that's the idea. As we're completing the course, we want students to have an understanding of how 3D printing works, how to be able to go from designing to slicing to printing, to be able to create these digital prototypes. The final exam will be on May 3rd through May 10th. There will be no hands-on drawing, just questions like from the midterm, where we want you to provide us with examples and links of the different types of technology that we covered within the class. So with that, I'm going to end the Zoom recording and post this for students to review. Al, is there anything else that we want to talk about before I end the recording and post it?
Just a couple of minor things. We enjoyed having you in class. Hopefully, you sign up for one of the other classes. See you there. Just a reminder, you need to come in. We'll be here on Sunday from 8:30 to 1. So if you need some help or if you have some of your projects, please come on by.
Alrighty, with that, I'll stop the recording and post it.